Quite to double. Now I am. Yay! I made it to double digits. All right, I'm just gonna go back to this because it's gonna freak me out. Let's see. Okay. Anybody with questions? I had a couple of good questions in office hours. Are you guys just trying to hang on for another week or so? Is that what's happening? Any questions? Are you guys trying the homework out? Because I know there's some weird shit in the homework. So I don't get questions, I get concerned. All right. All right. I'll leave you alone. Let's see. I'll be an optimistic fool. If there are no questions, we're just going to get right back into some stuff with conic sections, right? With the ellipses and the hyperbolas and the parabolas. So I'm going to run through the proof of the asymptote. We still have to do an example of a hyperbola, another one, right? We only did one. I want to do an example of an ellipse where the center is not 0, 0. That'll be a nice thing. We'll find out if you agree. All right. And a hyperbola. And then we got to talk about parabolas. And then we'll call it a night. So let's take a look. The first thing I want to show you, I really, really, really don't feel like just writing all this shit down. So I'm going to show it to you. In the book, they do. So here's the book itself has a decent, remember how I told you that an ellipse is kind of like putting a string down between two nails, and then you put a pencil here and you kind of go around as far as the string will let you go and you make an ellipse. So it basically is D1, this distance plus this distance has to be a constant. You guys with me? All right. And what they do is, if I put my pencil here, let's see, if I put my pencil here, then this is D2. I'm sorry, this is D1 and this is D2. So anyway, so that you could, if you wanted to, you could follow their logic along. They figure out the constant. There's D1, there's D2. That's the distance between these 2 points here, right? Add them together. It's got to be the same number throughout. So then they just work. And right here is where the important part comes in. This is what I really want to show you. Right here, they make the decision to call a squared minus c squared, they call it b squared. And that is where the formula for the, what do you call it? Foci comes in. If you add c squared and subtract b squared, there it is. There's the c squared equals a squared minus b squared. That's the formula for the foci. I like it. A very F-intense sentence I just said. Formula for the foci. All right. And the crowd goes meh. So I need to believe that ellipses are not a major concern. They should be relatively simple. So let's try a quick problem out. So here's one that's been shifted. So let's see, blah, 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 blah. Let's just do one up there on the board. Bam. Let me turn off my Starry Night stuff in the back of me. So let's do this. Let's talk about ellipses. Then we'll talk about hyperbolas. Oh my God, every time I do this, it takes longer. Here we go. All right, let's do that. Whoa, oh, crap. That is really close, Jeff. All right, let's push this back a little bit. Get out of here. All right. Why is this so dark? Oh, I see. Is that right? Nah, it's a little dark. All right, let's see how that works. Maybe we're on this way. Man, place to get crazy. All right, so if I have something like this. All right. Can somebody tell me where the center is now? Where's the center normally for an ellipse?
0, 0.
0, 0. I love it. So where, somebody else tell me, you should be able to tell me, where is the center now for this one?
2 minus 1.
Hold on. There we go. I'm messing with this thing again. 2 right, 1 down. I love it. 2 right, 1 down. Kick ass. I think I have shoved the idea of transformation deep into your brain. So now you see it immediately. I love it. How far away from the center do I go in the left and right, in the X direction? How far from the center will I go? Who remembers?
4.
4. So this is a squared. So a is 4, plus or minus. You go up and down. This is, of course, b squared. So b is 3. So I want to go up and down 3 from the center. I want to go left and right 4 from the center. And that's all you got to do. So if the center is 2, negative 1, let me see. So 2, negative 1. So I'm just going to put like a little circle here because it's not a point on the graph. So I'm going to put a little open circle. That's my center. And like we just said, you have to go 4 to the left and right. 1, 2, 3, 4. Look at Jeff planning ahead. 1, 2, 3, 4. And then you have to go 3 up and down from the center. 1, 2, 3. 1, 2, 3. I don't know what that looks like to you. Probably wrong. Yes, I can see it already. It looks wrong to you. All right. Now you guys, is that, I mean, come on. Right? Yes? Can you believe it? Compared to some of the shit we've been doing, ellipses are really nice. Can somebody help me figure out what the foci are? All right, sorry.
Five.
What did you do exactly? So the foci. So to figure out where C, what C is, it'll be the bigger one minus the smaller ones. So I mean, a squared minus b squared. Stay with me now. So for an ellipse, since there's a plus there, there's a minus in the focus equation. For hyperbola, there's a minus there, there'll be a plus there in the focus equation. Okay, so now I just know that c squared is a squared minus b squared. Square root of 7. Now be careful though. It's a lot like what we did for this. It's always in reference to the center. So I want to go square root of 7. Do I go up and down or left and right? Where's the major axis, obviously? Yeah, left and right. So I'm going to go square root of 7 this way. Square root of 7 is 2 point something. I have no idea. 2 point something. Nobody's going to help me. Oh, well, it's just the way it is. The way it is. Nobody's even picking up on the fact. Okay, that's right. So it's 2 point something. So 2 point something.
2.64.
Thank you. So if I go here, 2.64, a little bit more than half, and then 2, and then 0.64. So that's where the foci are. Foci. I love it. So it looks like dead Stewie. That's what it looks like. I don't know if anybody gets that reference. Okay. All right, so that's not that bad. All right, no. I'm gonna erase all this, and I'm gonna make it worse. All right, sorry. Let me erase all this. Let's see if you guys can remember some stuff. Here we go. All right. Oh shit, Jeff. Now I gotta make it work. Nah, all right, let's just do this. You're not gonna make it work? Be quiet. What about this? 9x squared plus 18x plus 4y squared minus 16y equals, give me a second. Am I gonna really try to make this work? Maybe. Enter. I think. I don't remember. Screw it. I don't care. All right. We're not going to graph this. I don't want to try to make this work ahead of time. How can somebody tell me, how can you tell this is an ellipse? And what the hell? Does this look anything like this? I mean, this is the form of an ellipse, like we just did. What am I going to have to do to try to get it into this form? What do I have to do? And how do I know it's an ellipse? What do you guys think? What are the coefficients of the x squared and the y squared? Are they the same?
Different.
They're different. That's an ellipse. Right. So they're plus, they're both positive, they're both the same sign, and they have different coefficients. So I know it's an ellipse before I do anything. Okay. I know it's not a parabola, for example, because both letters are squared. I know it's not a hyperbola because they're not different signs. So what do we have to do to make this look like this? What do I have to do? Process we haven't seen for a little while. No, not really. Completing the square. We've got to complete the square. So if I take a 9 out, leave some space, take a 4 out, leave some space. Does this feel at all familiar? How do you figure out what goes here? What do I do to this to figure out what has to go here? Does anyone remember?
One.
All right, that's great. Well, what did you do to get that?
1/2 of that.
Cut this in half and then square it. So half of this is 1 squared is 1. So I'm going to add 1. So what did I really just add?
9.
9. Oh, shit, Jeff. Make this a 21 real quick for me. I didn't think far enough ahead. So let's see. Oh, no, this is fine. Leave it 11. Jeff, you're silly, man. You're tired. Leave it 11. So if this is plus 9 here, I better plus 9 over there. And now, how do I figure out what goes here? Half of -4 is -2. Squared is 4. I actually just added. Ooh, did I make this work? Holy shit. That's neat. Yeah. I'm really sorry, guys. I don't know if anybody's with me. I just threw 11 out of nowhere, and this thing is going to work nicely. And you're all like, I don't care, dude. Just do it. I understand. Do you guys remember this? Completing the square? I told you it had more purpose than what we've used it for so far in the past. Does anyone not remember that and want to admit it? No? Okay. I'm going to assume everybody's here. Now I can factor. right, so this will be x plus 1 squared plus 4 times y minus 2 squared equals 36. That's amazing. So I'm going to divide by 36 to make a 1 here. And let's see what we get. We get x plus 1 squared over 4 plus y minus 2 squared over 9 equals 1. You guys all cool with that or okay with that? See how that works? The biggest mistake I see is people put stuff here and they forget to do it to this side also. To do the real thing that just happened to that side. Can somebody tell me what the center is?
Left 1 up to.
All right, so the center is -1, 2. I like it. And then, of course, I would go 2 away from this on the x direction, 3 away from that on the y direction. Okay, so once you get it into the right form, it needs to be relatively easy. Plot the center, go 2 left and right from it, go 3 up and down from it, done. Okay. All right, so I'm going to erase all this. So you're going to see some problems that look like this. If this was going to be a circle, can somebody tell me what would I change this into to make it a circle?
9.
Yeah, I have to change it into a 9. They have to be the same. And then it would act the same in the x and the y direction. That's why it would be a circle then. How would I make it into an ellipse, of course? Somebody else?
Different coefficient.
No, it's already different coefficients. How do I make it into a, what did I just say? Ellipse? Maybe. You guys get me at the end of the day. I'm sorry, I'm tired. Hyperbola. How would I make this into a hyperbola? Because it's currently an ellipse.
Minus.
Okay, make this a minus, right? Or make that a minus. As long as they're different sides, that's a hyperbola. All right, all right. Let me erase all this. All right, let's revisit hyperbolas. Okay. Let me see here. Here we go. So one of the main forms of a hyperbola or hyperbola is this. I could switch these around. The way I've written it so far, it would be a hyperbola opening here like this on the x-axis because the x is positive. We talked about that yesterday. We talked about the fact that there can't be any y-intercepts, which leads to that picture. It's like it's avoiding the y-axis, right? If I turn these around, it'd be up here and down there. Okay, now here's where things things get tricky. So that's why I had to, if I don't look at it for a while, I kind of forget exactly how I want to get this. So now watch this. I'm gonna just subtract 1 and add this. Is that cool? So I'm gonna make it y squared over b squared equals 1. No, I'm sorry, this minus 1. All right. So all I did was I added this and subtracted 1. That's all I did. All right, so now I'm going to multiply by b squared. Okay. And again, this is nothing that you would have to come up with on your own. I'm just kind of trying to catch you up with what has been discovered in the past, right? And they didn't exactly do this in a day either, so that's okay. So I'm going to do something a little weird here. Does everybody agree with me that I could take a b squared out? Of course. All right, just stay with me, stay with me. But I'm also going to take an a squared out. and over a squared out. Can anyone figure out what's going to be there now? If I take that out, of course, there's an x squared here. What's going to be left here? So I took a b squared out. Yes. If I divide by, so when I take something out, I'm dividing by what I took out. B squared divided by b squared is 1. 1 divided by 1 over a squared is a squared. And again, if you brought this in, don't you get back here? Okay. All right. I like it. You guys, well, somebody just left. They're like, that's it for me. I understand. All right. Now we're going to get even freakier. I'm going to take an x squared out. All right. Would you ever do that for any reason? Would you just go, yeah, I think that's a good idea? No, you would not. If you did, you'd be weird. You'd be one of us, the math people. Okay, now I'm going to take a square root of both sides. I really want you, everybody cool with me so far? I'm taking the square root of both sides. So this will be this. All right, somebody remind me. Horizontal asymptotes. Horizontal asymptotes. Where do they come from? When do they become strict? When do they, do you guys remember horizontal asymptotes?
Yes.
Yes, anybody else? Rio's with me. Do you guys remember? Y is undefined? No, sort of like. So horizontal asymptotes. Oh, forget about all this. Horizontal asymptotes. Sorry?
When x gets big.
Yes. So horizontal asymptotes come into play. So if my horizontal asymptote is 2, for example, my function can go like crazy and stuff, but it eventually has to start to go towards it. So it only cares about what happens when x gets big, positive or negative. So it only matters as x goes to infinity or x goes to negative infinity. That's the only time it matters. So what happens as x goes to infinity? What happens to this piece right here? As x gets really, really, really big, what's a? What is a? What is a? I like that, Kurt, you're right, but what's a? What's a? Isn't a just a number? Are you with me? Isn't a just a number? Yes, like 3 or something. Khalid, no. So as x gets really big, this gets really small. So when x approaches the biggest possible thing, which is not really a thing, as x continues to grow, this continues to shrink, goes to 0. Square root of 1 is 1. So then I get this. I get that. What the shit does that mean? I don't know. Okay, hold on. Yes, I do. Everybody stay with me. All right. So this is where I wanted to get to yesterday. And you can tell that it's a little bit tricky if you haven't done it in a while. I'll stop trying to get myself. Jeff, you want to see this? All right. Stay with me. Stay with me. Stay with this. All right. So watch what this, how this works. If I go A, aren't I going to go A in the x direction and I'm going to go B in the y direction, correct? Same way we did with ellipses. I'm going to go out A, wherever A is. Let's just say it's here in the x direction. Jeff, just freaking put it somewhere. Why are you putting the scale down? I don't know, Jeff. You've been sniffing the markers too much. Whoa. And in the B, in the Y direction, I want to go B. Can you guys see that this equation? Let me do this two ways. All right, plus or minus B over A X. What is B over A in that equation? What is B over A? What is it in this little equation? What is it? Algebra time. What is B over A? What is it? It's the what of that equation. What is the equation of? Come on, guys. What is that the equation of? Y equals number times X. What is that? Yes! It's the slope of the damn thing, right? It's exactly a rise or a run. So if I'm at 0, 0, and I want to rise B, run A, aren't I just going to go right through the corner of a box I can draw? Doesn't that mean I'm going to go right through that corner? Yes? That the line is going to go up B over A. So if I just draw a box all the way around, that's a shortcut. I can just go through the corners of that box, and I'm drawing those lines without even having to think about it as a line with a slope. I'm just drawing a box and going through the corners. It's a shortcut. And then this guy sits on the x-axis, so he's going to look like this. Yeah. Yeah. So let's try a real one. Let's try an actual problem out with some real numbers in there. And oh, by the way, before I leave this, do you see how make that a plus and I just get this as the answer, the ellipse here, right? Do you guys see that? So that is what I was trying to say. The ellipse is if there's a plus and then it explodes out if it's a minus. Okay, I like it, I like it. So let me erase this. We're going to put some real numbers down here. All right, actually, let me get everything out of here. Go away. Bother my students. Okay. So what if we have, let's do y squared. Y squared over, it doesn't matter, Jeff. Yeah, sure. 81 minus x squared over 25 equals 1. So this is nice because the center, of course, is at 0, 0. This hasn't been shifted at all. How much I'm going to move up and down?
9.
9. I like it. So I can call A 9. And so B is going to be 5. I'm going to move left and right 5. I really want you guys with me. This is way nicer than you might have thought it was going to be to graph freaky ass hyperbolas. All I got to do, I'm going to go out 9 in the y direction. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. 9 in the y direction. 9 in the y direction. In the x direction, I'm going to go out 5. 1, 2, 3, 4, 5. I'm going to put a little open circle here because that's not really a point. Because how do I know it's going to be up here and down there? How do I know that? And not over here. How do I know it's not going to be here and there? How do I know it's going to be?
Y.
Because the y is positive. Yeah. So now I'm going to make my little box. You can do whatever freaky ass sound effects you want. It's totally up to you. Why am I changing colors? I don't know, just because. And now if I draw a little thing, now I'm drawing in my asymptotes. The box captures the slope of the line. Bodacious. And now when I go to graph my answer, it just has to follow eventually these. So it's kind of fat. I like it. So again, if that was a plus, I would have just connected these with an ellipse. Since it's a minus, I do it on the other side instead. Right, inside for an ellipse, plus minus makes it on the outside here or there, depending on which one is negative. Okay, not bad. Okay, I like it. I'll stop. Now, all right. The cool thing is, if I shift this, let's see. Yeah, let's see. All right. I'm gonna erase all this. You ready? You ready? Okay. The really nice thing, if I have a shifted hyperbola, let's see, if I ever have this, I'm going to put that over 1. Bam. So it's been shifted. I know that A is 2 and B is 1. So I'm going to go 2 in the X direction, 1 in the Y direction from the center. Where am I at? Okay, so the center is going to be -2, 3. Okay, I'm assuming everybody can see that. So it's going to be -2, 3. So -2, 3 is going to be right there. Trying to make it look right from your perspective. The nice thing is everything is the same as it was before. Just count from the center. So from the center, I'm going to go 2 in the X direction. So you go there. I'm going to go. You can do it, Jeff. There. My scale's a little freaky. I don't care. I'm going to go up 3 and down 3. So up 3, 1, 2, 3, and down 1, 2, 3. Make my little box. Make my asymptotes. Right, and the X is positive, so it's going to open this way in the X direction. So it's going to go like that. It's going to go like that. Cool. So that if it's been shifted, it's really not different. How to graph it doesn't change. It's kind of too nice to believe. All right, and of course, I could give you a problem where the completing the square hasn't happened yet. So you have to complete the square to make it look like this. So if you forgot how to complete the square, the thing we did earlier, go review it. It's a very useful thing to know in a few different areas of math. Okay, so we're going to leave hyperbolas behind for a minute. Not for a minute. We're going to go into parabolas now. And this is one place where I want to step through the whole thing with you. Step through the whole derivation. Because we do already know stuff about parabolas. So it's a little weird that there's a whole different way to look at them. So the definition of a parabola, the parabola's definition is weird. So the definition of the parabola is all the points. Now stay with me, stay with me. This is weird. All the points on a parabola are such that they are equidistant. Oh shit, stay with me. They are equidistant from this line and this point. So the line y equals -p and the point P. So for example, stay with me, stay with me. This would be a point on the graph, right? Because it's P away from that and it's P away from that. Now, obviously why can't this be a point on my graph? Because it's further away from that than it is to that, correct? I love you guys, I love you guys. I don't know. I don't know. I just get one. I can see one person shaking his head yes, and I'm like, that's all I need to keep going nowadays. So it's going to have to be over here somewhere. Maybe my stuff is a little weird. Let's see, maybe there. So this distance and this distance, probably not quite far enough, but you get the idea. So these two distances have to be the same for it to be on the graph. So it kind of makes sense. It's going to be this curvy deal here. It can't go straight out. It can't go straight up. It can't go straight out. It's got to be in a curve going away. So we're going to prove that. So here's distance 1 and here's distance 2. And this is a point XY. Now, let me say this is very strange. As I don't know if anyone's ever heard of this. You guys didn't even know there's a whole definition of a parabola that is something other than it looks like a U, right? So there, the definition of parabola is a collection of all points that are the same distance from this point we call the focus. Oh yes, there's the focus. And this line, get ready, kids. This line is called the frickin' directrix. Excuse me? Okay, I know. Sounds like a character from the Matrix movies. But, or maybe it's just me. That might be just me. Okay. Can somebody tell me what this distance, let's see, let's do this. What is this distance here? This is the easy one. It's straight up and down, correct? Straight up and down. So how far is it from here to there? How far is this? And then I got a little bit extra, correct? So what is D2? It's going to be this plus this. You could do it. How far is this? How far is this? How far is this? How far is this?
P.
P, right? It's P. That's negative P. So it's exactly P down plus, somebody else tell me, how far is it to that point? How far up do I go? You do. How far up do I go? How far up do I go? You can do it. What's the point? What's that point? Isn't the point X, Y? So how far up is that point? I'm not asking you for a number. I'm not asking you for anything other than what I've already told you. I'm just asking you to say it. Oh, I see, Charles, you're trying to mouth it to me. Okay, I like it. I can read that. I was going to say I can't really read lips, but I can read the why. Why? I hear how I love it. You're like, look at me. All right. So is everybody please, dear God, please, this is not impossible to understand. So that's P away because that's freaking negative P. So of course it's P away. And that of course is Y away. That's how high up it is. So D2 will always be P plus Y for any point that's on this. What is D1? I don't know. What point is this? What point is this? What point is the focus? What point is that? What point is that?
Zero Y.
No, 0Y would be here.
0P.
0P, kick ass. So P, this P thing controls everything. Do you see that? This little P dude controls everything. All right. So can you guys take a minute and figure out how far that point is from that point? Go. Don't say anything. Just calculate the distance from this point to that point. That's all I need. Oh, I need that distance. You guys remember the distance formula, right? So let me do it this way. It'll be x minus 0 squared, so x squared plus y minus p squared. Somebody cool with that? Somebody cool with that? All right, now, so what do we say has to be true about these two distances? What's the fundamental property of parabolas? These two distances have to be freaking equal. All right, so just stay. I'm just going to do some algebra real quick. You should be able to follow pretty quickly. I'm going to square both sides, so then I can square this. All right, is that cool? I'm squaring both sides so I can kill that square root. I'm going to FOIL this bad boy out. Right, you guys can all do that. Nothing amazing is happening up here. You're like, that never happens. Be quiet. So the y squares die. See that? Isn't that nice? Y squares die. P squares die. And I can add this over here. So I get x squared equals 4py. That is a funky ass way to write the equation of a parabola. I'm being told it's called parabola. Okay. No? Yes? All right. Grab with me. Now real quick. Something interesting. Well, let's do this. Let's do a concrete example. Let me take all this away. And we'll do a concrete example. Let me think. How do I want to do this? Well, all right. No, we're not going to do a concrete example yet. Too bad. I've changed my mind. I'm going to take this away. So this, of course, is going to end up being a parabola, kind of a fat one, the way I've done things. Stay with me. Stay with me. Oh, I love it. I love it. You should take Tylenol before class starts. Now, here's something very interesting. I don't know if you guys are going to agree with me. One thing is, do you guys realize that a lot of satellite dishes are parabolic, right? If you have dish TV or something, they're parabolic. Sometimes they're hyperbolic, but very often they're parabolic. And those two words are related to the graphs we draw, but they're kind of related to the curvature of it. So you have telescopes that are parabolic, possibly parabolic mirrors, parabolic lenses. All right. So mirrors, more, yeah, parabolic mirrors. There's an interesting. I got a lot of shit happening up here, but let's see if you guys can hang with this. Right at the focus, there's an interesting thing about how wide this thing is. Right at the focus. So now watch this. No, stay with me. This is really neat. So whatever point, and again, I got a lot of shit up here, but it's just too bad. You're gonna have to deal with it. Whatever point this is, and whatever point this is, what is the output at those points? You could do it. At those points, right across from the focus, what is the output?
P.
P, right? Because that's the output, because it's where the freak it is, right? So let me go ahead and plug a P here, because that's what the hell it is. Yes? At that point, at those points. I know. Come on, you guys can do it. Stay with me. Stay with me. So I get x squared equals 4p squared. So I get x equals plus or minus 2p. So at the focus, I would go up 2p to see where that point is, and I would go down 2p to see where that point is. So what's called, I know, oh God, I know, guys, I know. You're all like, why are you screwing up parabolas, Jeff? They were so easy. What the shit are you doing? Well, this has everything to do with constructing parabolic dishes in certain dimensions to do certain things. So here's the neat thing, a little physics, kids. The focus is called such because if light rays come in, they will always go towards the focus. So if you make a parabolic mirror telescope, all the light comes in, gets focused here. So this is where you want to put your camera. This is where you want to put the thing collecting the light, right there. So very often, if I have a parabolic telescope, there will be a little seat right here for somebody to sit in, because that's where the whole image is going to come. B is right at the focus. I love you guys. I love you guys. Now, so this focal diameter, do you see if it's 2p up and 2p down? Isn't the focal diameter 4p? Obviously, right? 2p up, 2p down, 4p across. So that's why we call it the focal diameter. It's the distance all the way across through the focus. Focal diameter. Oh, okay. I know you're all like, all the little shit you do, Jeff, doesn't help. I'm sorry. All the little O and the O and I. And... all right, it's just for me now. So let's do a concrete example. So if I could figure out what P is, let me put this, oh, there it is. So let's say I have x squared equals 8y. The most important thing to know is P. Can somebody tell me what P must be? The general equation is 4py. This is 8y. What is P?
2.
2. Thank you. All right. 4py. 8 means there's a 4 times 2. Do you see that? So really, you just got to divide this number by 4, because the rest of it will be what P is. So now I know everything. I know, ouch. I know the focus is at 2. I know it goes through 0, 0. I also know, can somebody please tell me what the focal diameter is? I should be able to, because it's right there. And actually, I should put an absolute value on this, because P could be negative, because it could actually be down here. What's the focal diameter? It's going to be 4 times P, so it's 8. I really want you guys, if I know P, I know everything. Probably a phrase you never thought you'd hear in college. If you know P, you know everything. But if I go up and down 4 so that I get a length of 8, 1, 2, 3, 4, 1, 2, 3, 4, that's where it goes from the, and now I'm done. Now I'm done. I've graphed it, because I know the diameter at the focus is 8. So I go up 4, down 4. Done. All right. Okay. All right. So what do you think would happen if it was this? What's the difference between this and the one we were just doing?
It's y squared equals instead of x squared.
So I switched the x and y. So what do you think that's going to do to the graph? Where else have we ever switched x and y? And what does it do? Yeah, there you go. It's just gonna take this and switch it down there. So this is going to look like this, with a vertex and a diameter going this way and this way. I would have done everything the same we did. I would have just done it that way, right? That's all. It would have been exactly the same. Okay, so I know that's a very strange way to look at parabolas. You never looked at parabolas that way before. This is a more useful way to talk about them, though, not only because it directly relates to the definition of a parabola, which I doubt anybody's ever heard. Has anybody ever heard of a directrix before? Directrix? It sounds like when the robots take over, like the lead robot is going to be the directrix. I don't know. And it has to deal with constructing a parabolic mirror or whatever it is to conform to certain things. Where do you want the focus to be? Do you have constraints because of how much room they have to build in? You can change where your focus is going to be, and you can see how wide it's going to make it. All right. That's enough, Jeff. It's enough selling of the idea. Okay, so I'm going to erase all this. And I'm going to see if you guys took good notes. All right. So try this here. I'm going to be a little, well, let's see. How much of an asshole do I want to be? I don't know. I'm not going to be an asshole. Let's see. Well, let's be a little bit of an asshole. I like it. There we go. So try to figure out what P is. Try to figure out what the focal diameter is. So again, I just have to remember x squared is 4py. So whatever's in front of the y is equal to 4p.
I'm sorry, but why do you ignore y?
What do you mean ignore y? How do I ignore y?
Like when you take a square,
What?
you make it x equal. Like, why there is not like why did you make a 2p plus minus 2p? There is no y.
I don't understand. What do you mean? There's a y. All right, try again because I don't really get your question.
But yeah, you erased it already, but
Yeah.
before you made it like x squared equal to 4py, then you took a squared and made it 2p.
Oh, okay. So, all right. I got you. So I was curious what this point was and this point was. What inputs would make the output P? You with me?
Yes.
So I was curious, when am I going to get the point XP and negative XP? So what do I know about both points? I know the output is P. So couldn't I put P in where Y is?
Oh yeah.
There we go. That's the step you lost. I want the output to be P, so I make the output P.
Thank you.
Sure. All right. Now, to figure out what P is, what does 4P have to equal? What does 4P have to equal? What's in the right place for 4P? What does 4P have to equal?
About 2.
Yeah, 1/2. Isn't that in the right place? So then I can figure out P is 1/8. No. All right. Then the focal diameter is 4P. So that would be 1/2. Right? 4 times 1/8 is 1/2. Stay with me now. Don't freak out just because they're fractions. So I know this is going to be, let's see how I want to do this. It doesn't matter. This is 1/8 is where the focus is. And then I want to go out. How far do I want to go out? Do I want to go 1/2 out in both directions? How far do I want to go in both directions? I want the total diameter to be 1/2. So I actually want to go out 1/4, right, you guys? So I want the total distance here to be 1/2. So I have to go up 1/4 and down 1/4. So I know there's a point here. I know it goes through 0, 0. And I know there's a point there. And I'm done. Okay. So fractions are really not bad, especially because you can make your own freaking scales, right? You can make your own scale. So don't make your scale 1 and then try to throw 1/8 in there. Holy shit. Be nice to yourself. Make a fractional scale. You're allowed to do that as long as they're consistent. You can make the scale anything you want it to be. Okay, all right. I don't know if you guys heard that. Let's see. Okay, I think that was, yeah, that's plenty for this week, huh? What time is it? That's not too bad. What do you guys say? You think that's plenty? Plenty of that? You guys want more? I always got more. You want more? All right, if nobody says anything, I'm going to do more. I got 1 no, and that's all I got. So I think I got 1 no versus 11 yeses. So I'm going to do some more. Here we go. It's too bad. You snooze, you lose. Let's talk about, let me see. I don't have anything. No, all right. Everybody wants more. All right. I got a very polite no gracias. No, thank you. Very nice. No, thank you from somebody else. I'm trying not to take it personal. No, you've had enough of me. I understand. Anybody else? It's fine. All right, I'll stop being an asshole. You guys don't wander away too far from your computer because you might have a nifty question like that, and then you'll be free. So you're free. Go. Let me know if you need to hang out afterwards. Otherwise, go. So next week we'll do a little bit of chapter 13. We'll probably make a couple of sections extra credit. I told you I could if I wanted to. We'll see. And the practice final is there for you. Okay. So let me know if you need anything. Otherwise, I'll see you next week.
Thank you.
You're welcome. Everybody good? All right. I'm
Yeah,
out.
Professor, just one question. Is the final gonna be next week or in June 6th? I'm not sure.
Have you ever looked at the homework sheet?
Yeah, I look for the homework sheet, but I think I don't look for the final. Let me just check it. Give me a second.
Here we go. I'll show you.
Oh, June 1. Okay.
Yeah. So next week is review for the final. Wednesday.
Oh, okay.
Yeah. And then the week after that is the final. Yeah.
Okay. Thank you so much.
You're
Have a
welcome.
great night.
You too. All right. Everybody else good? Okay. I'm out of here.